This is 4.3, day 3. This should be the last of it. So what we're doing today is I have, I think, about 6 problems on this page. I think another 5 or 6 on the next page. We need to evaluate. We're going to use that unit circle. And so going back here, I filled in the unit circle for us. What we should have done is use all of our triangles, using those 2 reference triangles that are up there on the top right, filling that in, creating this beautiful unit circle that is very handy, very compact, a lot of information here. Again, the only information that's not necessarily on this unit circle right now, because you have your reference triangles, is the fact that each set of points is called what? Cosine theta, sine theta. Now be careful, we say cosine theta, sine theta. The book, or another book, or some other problems you may come across, they may take theta out and put alpha in there, or t in there. It doesn't matter what you put in. You just know that when you take a sine, cosine, tangent, cosecant, secant, or cotangent, you're taking it of an angle to find a ratio. So therefore, it's always on the unit circle, cosine, comma, sine. Cosine, comma, sine. And the last piece that maybe we should also put on there, because it's going to ask us for tangent. Tangent is made up of sine theta over cosine theta. So again, those 2 pieces there with the unit circle is going to allow us to answer pretty much any trig function, with the caveat that it has to be an angle or a coterminal angle of 30, 45, 60, or 90. That's the limitations of the unit circle. We only can find angles that are the nice angles, we call it. Of course, could you technically come up with reference triangles for a 25-degree triangle with a, was it 65? Sure. But those ratios, those numbers are different than the rest of them. But there are ways. We just chose these ones because they seem to have some nice numbers. Okay? So, what do we have to do? So when evaluating a trig function, step number 1 is take a look at the angle of that function. If it is between 0 and 90, I'm happy, I'm going with it. If it's not, I'm going to find its reference angle. And the reference angle, remember, is an angle that references the first quadrant. There's issues with that. The issues are, sometimes I have to go around the circle several times when I'm graphing it or making a sketch. So do that. The other issue is, the reference angles are always a positive angle between 0 and 90, which references the first quadrant, which references those 2 reference triangles that we had on our paper, or on the board last, and they're always positive. So therefore, we also have to remember the all students take calculus. All schools torture children. You need to remember that so that you know that if you're in quadrant 2, sine's the only one that's positive. So, yes, find a reference angle. It's easier. It's smaller. I should know. Technically, we shouldn't even need to use the unit circle if I always find a reference triangle. Because you should know the sine of 30. You should know the cosine of 30. And if you didn't, we technically could just use the reference triangles because we have a reference angle. 2, I want you to find the value of that trig function for the reference angle. So again, an example, without having to do one of these, is that if I gave you a 390 degree angle, so sine of 390. Well, 30 is a reference angle to 390 because I go once around the whole circle, and then it'd be left over with 30. So you would have the sine of 30. And then you just look up, what's sine of 30? Oh, it's a half. So we've got to find that ratio, that value of that reference angle, and you're almost done, because step number 3 goes back to that whole idea. Where is it? Is it quadrant 1, 2, 3, 4? Is the trig function positive or negative there? So all students take calculus. You need to remember that. You need to realize that. Now, if I had the unit circle, I can just go here and say, look, 390. Whoop, I'm at 360. I travel another 30. There I am. I'm in quadrant 1. All answers are positive. So even though I talk about the reference being 30, the angle itself will have values that are going to be positive. Sine of 30 is 1/2. So the unit circle takes a little bit of those steps out of the question. Because wherever it lands, so if I land wrong. So if I go here and say I land at 135, it's automatically going to tell me that the cosine's negative and the sine is positive. They both have the same value of square root of 2 over 2, but one's positive, one's negative. So the unit circle helps eliminate a little bit of what sign is it. But step number 3, if I'm just using reference angles, I want to definitely hone in on, okay, I know I'm in quadrant 3, sine and cosine are negative, but tangent is positive. So it matters where we're at. Now I tried giving a little bit of a mix here. We have some degrees and we have some radians. And we also have a mix of sine, cosine, and tangent, and actually looks like the little 3. So you're going to have to do a little bit of a switcheroo. And it's okay. So again, I don't remember what the actual ratios are for the little 3. Because what I'm going to do is I'm going to take the little 3, switch them to the big 3, and then take the reciprocal. Or figure them out that way. And so tangent of 5 pi over 3. I don't like tangent. I'm going to switch it to what? Sine over cosine. So, if it's tangent of 5 pi over 3, it's going to be sine 5 pi over 3 over cosine 5 pi over 3. And then, now, you can evaluate each of these. Now, if I'm using the steps from above, is 5 pi over 3 a reference angle? I don't think I'd use 5 pi over 3 as a reference angle. Now we have options. Option number 1, just go to the unit circle. Where's 5 pi over 3? I'm backing up here. 5 pi over 3 I see is here. Oh, well, that's 300 degrees. Now I'm not thinking of it as 300 degrees. I'm thinking of it as sine of 5 pi over 3 over cosine 5 pi over 3. Well, here's a cool thing. What's sine of 5 pi over 3? Which value? The y's. So, it would be negative square root of 3 over 2. I don't even have to think about that. So it's negative square root of 3 over 2. Over! Going back. Cosine of 5 pi over 3. Going here. 1/2. Look at that. I didn't have to worry about steps 2 and 3. Or actually, well, even 1 or 3 actually, because I just went to the value of the trig function at theta instead of reference. And I didn't have to worry about the signs because the sign already came along because it's on my unit circle. So it's really cool that I can use my unit circle that way. Now, of course, I got a complex fraction. I got a fraction, divide by a fraction. I don't like it. I'm not leaving it. So therefore, I need to do what? Multiply by the reciprocal, 2 over 1. What happens with the 2's? Cancel. Remember that negative doesn't go away. It's negative square root of 3 over 1, which is just negative square root of 3. Now, just for fun, take your calculators out. Make sure you're in radians. You have a tangent button. Let's test it. Let's make sure your calculator and you know how to use this. take the tangent of 5 pi over 3. Make sure you're in what mode? Better be in radians, so switch it out. If you're using a graphing calculator, switch modes. If you're in the gray standard box one, you have to hit the DRG button to says rad above. If you got questions, please speak up. Now, how the heck do I know if I got that right? Because right now there's a decimal on your calculator, isn't there? Is it a negative decimal, first of all? Okay. Now, if I want to know if it's a square root of 3, if I squared it, I should get what? 3. Square it. Do you get 3?
Yeah.
Yeah. So that means you actually had the negative square root of 3. 1.73? Is it? So it's a negative 1.73, la-di-da-di-da. Pretty cool stuff. Now, let's think about this a little bit further. Let's actually now use steps 1, 2, and 3. So I'm going to work into space B there. If I wanted to actually do this without a unit circle, well then I have to graph it. And we already said 5 pi over 3 would be 1, 2, 3, 4, 5. So I am here. Would you guys agree with that? I mean, we just looked at the unit circle. It was definitely in 4th quadrant. What would the reference angle to that be? What would the reference angle to be the 5 pi over 3? How many more pi's over 3 does it take to get back? 1. So the reference angle is pi over 3. So you know what this means? It means that the tangent of 5 pi over 3 is equal to the tangent of pi over 3. Except for there's one small issue. Everybody take your calculator out right now and take the tangent of pi over 3. Do you get the same answer? Essentially, yes, but no. What's the difference? This one's positive. I said what when we first started doing this? All reference angles reference which quadrant? Quadrant 1. All trig functions in quadrant 1 are positive. You need to actually deal with step 3, I think, sometimes before step 2. Because these are not equivalent the way they stand. You know that in quadrant 4, tangent should be negative. So guess what? I'm going to put a negative in front. Put a negative in front of tangent of pi over 3 because now they are equivalent. And now, wait a minute, using the same exact thinking I did last time, this is negative of sine pi over 3 over cosine pi over 3. Only one negative on the outside. What's sine of pi over 3? Look at your unit circles. Going back here, here's pi over 3 right there. It's the square root of 3 over 2. So it's a square root of 3 over 2 over 1/2, which is a negative square root of 3 over 2 times 2 over 1, which is a negative square root of 3. It gave us the same answer. 1, I went directly to the unit circle. Second option, I found a reference angle, checked it with all students take calculus, and then evaluated it. Step number 1, or the unit circle method, works if your angle is between 0 and 360 or 0 and 2 pi. Option 2, which is the steps laid above, work really well if you have something that's bigger than that. Something that I have to find coterminal angles for, right? So now I'm talking maybe 54 pi over 6. Or 2. Or something on those lines. Something you're going to go around that circle several times. Okay? Everybody have the idea of what we need to do? I'm going to take away part B, all that stuff after, because we do have an answer for that. And I want you guys to try part B. Okay, guys. We have options. Option 1 or option 2? Which one did everybody do? Did everybody just go to the unit circle? Is 5 pi over 6 on the unit circle? Yes. I think that's what I would do. I'd go back here, and that was a sign, right? So 5 pi over 6 is here. Sign is the y value. The answer? 1/2. Now, if I used option 2, I would be like, hey, I am here. What's the reference angle, the leftover, or the not leftover, but how much more do I need to get to the x-axis? Pi over 6. So this would be the same thing as pi over 6. Sine of pi over 6. Do I need to change the sign? In second quadrant, all students, S, sign is positive. We're good to go. So therefore, sine of pi over 6 is 1/2. I don't think it gets too much easier than that, right? That's a pretty easy one. Secant, now we have to switch it up a little bit. Try this one on your own. This time we're in degrees. Awesome, right? But we have secant. I don't like secant. Change it. What does it become? Secant is 1 over cosine. So 1 over cosine, negative 135 degrees. Wait a minute. Is negative 135 within 0 to 360? No. We have two options here. I'm going to obviously not go to the unit circle on this unless you can figure this out. I mean, you can. Or I'm going to use step number 1. I'm going to find its reference angle, or aka coterminal angle first. What is the coterminal angle to a negative 135? Coterminal angle would not be 45. Coterminal would be, what other angle would end in the exact same spot? 225. So would you guys agree that this should be the same thing as 1 over cosine of 225? That's because negative 135 ends me here in the third quadrant, but that's going backwards. The coterminal angle wants to go forward. And how did we figure that out? How did you figure out 225? Was it? You just went backwards. That's one option to do that on your unit circle, of course. Or what's 360 minus 135? Or what's negative 135 plus 360? So that I was able to get 225. Now, wait a minute. Is 225 on my unit circle? Yes. So I can now go to this and say, oh, cosine of 225, it's right there. Cosine is the x value, and it's negative, right? So negative square root of 2 over 2. I don't like when I divide by fractions, so I'm going to flip it. I don't know if I like that either. So I'd have to fix that now. Multiply the top and bottom by square root of 2. So I end up with negative 2 square root 2 all over 2. Oh wait, that's just negative square root of 2. Now, going back to what Ben had said, negative 135 has a reference angle. So instead of going all the way around, I could have said, what's the take to get to that x-axis right here? Pi over 4. Now, I'm in third quadrant. Cosine in third quadrant is negative. So shouldn't this be 1 over the negative of cosine of 45? Again, this is just another way of doing this. And therefore, it's 1 over negative square root of 2 over 2, which leads us to the same answer. So there are multiple approaches, at least 2 different approaches to doing this, finding coterminal angles, using the unit circle, using reference angles. It seems like those first 3 did a lot. We already switched some things to different trig functions, and we used both reference and unit circle. Let's check the next page to see if there's anything a little bit different on here. Yes. Let's do H. H has got radians and the fact that 13 pi over 4 is bigger than 2 pi. So try H, and we're going to come back together on that one. So what's maybe a first step on this one? I don't like 13 pi over 4. Find a what? Coterminal angle first. So if that's the case, I need to subtract 2 pi, right? 13 pi over 4 minus 2 pi. Wait a minute, I can't use 2 pi as 2 pi. I need to change it to common denominator, guys. 8 pi. Can I just do that right there? Look at that. I just changed it to 8 pi over 4. Because that is 2 pi. What is 13 pi minus 8 pi? Five pi over 4. So wait a minute. So you're saying that sine of 13 pi over 4 is the same value as its coterminal angle of 5 pi over 4? Yeah? We then can graph this if we wanted, or go right to our unit circle. Which one you guys want? Unit circle. Turning back, 5 pi over 4, where are we at? What quadrant? 3, 5 pi over 4. What's the sign? Equals negative square root of 2 over 2. Hey guys, hint, anytime you have a sine or a cosine of a pi over 4, you know it's going to be what ratio? Every 45-degree angle.
It's going to be
Square root of 2 over 2. You just need to decide, is it positive or negative? Start to recognize some patterns. Are there any questions on that? It'd be no different than if I did the tangent of 15 pi over 6. Instead of subtracting 8 pi over 4, I'm going to subtract, what? 12 pi over 6. It's the same thing, 2 pi. 360, I'm just going to start subtracting multiples of, or 960 there, 360. Subtract 360, is it enough? Probably not. Do it again. If that's not enough, do it again. Find a reference angle, use your unit circle. Okay? Any questions on this, guys? How about day 3, 4.3, day 3, page 251, 43 through 57, odds. Have a great day.